Alright, so some more LeetCode. I think this will probably be the last LeetCode. Not last forever, but the last LeetCode I do until I move on to system design. Alright, so yeah, let's just finish out arrays and hashing in blind 75. I believe I left off on encode and decode string. Make sure. Interesting. Diff arrays, hashing, encode, decode. Let's say I do something like why is it saying that this was modified? I don't think. Alright, anyways, that's okay. Alright, so we left off on encode and decode string. Encode and decode string finished. Alright, so what's next? Next is going to be product of array except self. Product of array except self. Product array except self. SPP and MD. Let me just copy over the template. St except. Alright. Let me copy this over. Not implemented. Alright, and con size t and dot size. Alright, so we are going to be given an integer array nums. Return an array output where output I is a product of all the elements of nums except nums I. Okay, so return an array output where output I is the product of all the elements of nums except nums I. Does that make sense? So this input 1, 2, 4, 6, we have to return an output array of the same size, and then we have to return for each element in the output array, it should be the product of the entire array except the self, right? So this spot will be 2 times 4 times 6, which is 48. Right, 24 would be 1 times 4, which is 4, times 6, which is 24, and this one would be 1 times 2 times 6, which would be 12, and this one would be 4 times 2 times 1, which is 8. Okay, makes sense. This case right here, -1, 0, 1, 2, 3. So this would be 0 because this has a 0, right? -6 would be -1 times 1 times 2 times 3, and then the rest would be 0. Okay. Constraints is nums I can either be -20 to +20. Nums I length is relatively huge. Let me see if product of array except self. Did they give us a different one? No, it's relatively the same. Can you solve the problem in O of 1 extra space complexity? Okay, let's not focus on this first. Let's just do this. Alright, well, let's copy this and put over. So we are going to have 1, 2, 4, 6. So automatically, when I hear product of a bunch of things except for itself, right, that's just a math property where if we take the product of this entire array, right, to be 1 times 2 times 4 times 6, right, what would this equal? This would equal 48, right? And if we wanted to fill, let's say this was our output array, right, 1, 2, 3, 4, right, this was going to be 48, right, because 2 times 4 times 6 is 48. But for this part right here, and for every other part as well, all we can really do is just take the product of the entire array and then divide this part by that product to give us this answer right here. And this is what I mean, right? So if the product of the whole array was 48, if we wanted this part of the output array, all we have to do is just 48 divided by 2, which is equal to 24, right? 24, same thing for here, 48 divided by 4, which would just be, what would that be, like 12? And 48 divided by 6, that would be 8, right? So 48, 24, 12, and 8. 48, 24, 12, and 8. I'm pretty sure that could just be it, right? I mean, is it saying you must write an algorithm that runs of event time? Oh, without using the division operation. Okay, so that rules that part out. So no division algorithm, right? Alright, I guess we can note that. So here, caution, no division can be used in an algorithm. We also have some preferences, right? So expected runtime should be of n. The expected space complexity is going to be, can't type, O of 1, right? So this kind of tells us that no extra data structures should be used. Okay, so I guess again, let's think about a brute force solution. Brute force solution could be something like this, where we have our output array, right? And for each index, it would just be the Gauss pattern, where for each index, we're going to take a look at the rest of the array, compute the product, and then store it into here. Now for this index, look at the rest of the array beforehand and the rest of the array afterhand, and compute that index right there. And then same thing, right? The issue with that is that that would be O of n squared, right? But that is the naive and brute force solution, I believe. So I'm gonna write that down. For int I to n, right? And for int j to n, if I is equal to j, then we would just continue, right? Else we would probably have a product here starting at 1, and then we would just say product times, or we would also have our answer vector here, right? So we would say int at I is going to be equal to, and we probably reinitialize the product here, right? So we would say int is equal to, actually we would just probably honestly say product times equals array at j, right? And then after this for loop, it will be int at I is equal to product. Yeah, so iterate through all the elements in the input array, right? And then for each of the elements, right, and making sure that we skip the ones where we're comparing it by itself right here, right? If our I was here, then our J would only look at this one, skip this one, go to this one, and go to this one, right? And then we would compute that product and then store it in our answer at I. So that is brute force, right? A couple issues with this though is runtime is going to be n squared, and space complexity would be O of 1, yeah, because we're not creating any extra data structure, right? So second method, what would the second method be? 1, 2, 4, 6. Okay, I'm gonna actually expand this one out to, let's just say we had a 3. Okay, say we wanted the answer for our output at I is equal to 2, right? At I is equal to 2. That means that we want the product of the left side and the product of the right side, right? Because that's the product of everything besides itself. So, I mean, how can we compute that, right? Well, we're just going to go from 0 from the left-hand side all the way to I, right? So all the way to I, exclusive, right? Inclusive. And then compute the products from, again, excluding I all the way to n, right? Inclusive. Or I guess n minus 1 inclusive, right? And then, okay, so if we were to compute the product of the left-hand side, let's just say left product and right product, then in order for us to get the answer, right, we just have to combine these, and given that it's just the product of the array except itself, we would just multiply these two products together to get us the output I, right? So to me, it sounds like all we have to do is find the left-hand side product and the right-hand side product, and then multiply them together to get the overall answer, right? Now, if we were at the beginning or the end, it essentially still be the same thing, right? In the case that we were here, again, we would go from 0 to I exclusive, and because I is at the leftmost edge, that basically means that we don't have a left product. And then the right product, right? We're going to calculate the right product. And we're essentially going to do this for each element, right? But doing this for each element, again, is going to be O of n squared, right? Because for each one, you're essentially just looking at the left and the right, right? For this one, you're looking at the entire left, entire right, and so on. So that's O of n squared, so it doesn't really help. Maybe though we can pre-compute these values, right? Because say we had an array. Say we had an array, right? And array, right? Say this was our left product array and this was our right product array, right? If we were to pre-compute these values for every value in here, right? So 1, 2, 3, 4, 5. Same thing with this one, right? 1, 2, 3, 4, 5. Then in order to build our output array, it's simply just this times this, right? This times this, this times this, right? And so on. And by left product array, I essentially mean this, right? So for each one of these ones, for each of these elements, we're going to build the left product, right? Again, since we're at the leftmost edge, there isn't really a left product, so this will be 1. It's important to not put it at 0, or else that will mess up our product. For this one, the left product will be 1, right? Because it's just 1. This one, it would be 2 times 1, 2, right? This one would be 2 times 4, 8. This one would be 24, 48, right? So, yeah. And if we do it for the right product, right? Again, if we were, let me just raise, no. Alright, I messed that up. But essentially, if we reduce the right product, right, the right product I here would be 2 times 4 times 6 times 3. What is that? 48 times 3. 48 times 3 is like 140 something. 48 times 3, 144, right? I think 48 times 3. Yeah, okay. So 144. 144 would be here, right? And then you would do the same thing, right? Keep computing, right? And you're just essentially computing the right hand side. So 144 here. At this point right here, it would be 4 times 6 times 3. 24 times 3 would be 24 times 3, 12, 6, 72. 72. Let's just say it's 72, right? And let's say we're at 4, right? So the right hand side product would be 18, right? 18. So this would be 18 here, and if we wanted the output array, the output answer at this index, at index 0, 1, 2, right, it would be 18 times 2, 36, right? Which is the product of the array except for 4, right? So it's just 18 times 6. So we're pre-computing it, and then we're just adding it up to build our output array. This is just O of n, O of n, and then to build our output array is also just O of n. So runtime would be O of n. Alright, sorry, I'm back. Alright, so back to what I was saying. Yeah, so basically we just pre-compute these left products and the right products, and then we just combine these together to build our output array. It's like the same idea that we were doing here, but the issue is that we're not doing it in one loop, we're doing it in multiple loops. So one nested loop, bad. Multiple loops, good, for some reason. Alright, so here, pre-compute left products and right products, right? So the idea is that, so this is our pseudocode, right? CPP. For each I in input array, so left product, this will probably be a vector, right? So a vector of, let's just say left p, right? So left p is going to be equal to I. And then in order to build our left products, let me use this example again. So say we had 1, 2, 4, and 6, right? To build the left product, all we're going to do is just, it's kind of like dynamic programming where we're building it up, right? So the left product of this at this part is basically nothing, so it's just 1. The left product of this is what this was times this number, right? 1, right? The left product of this is this number, right? So this number times times this number right here, so that'll be 2. And the left product of 6, right, is going to be this number multiplied by this number, which is just 8, right? So that's the idea of getting it to O of n, right? Because if we were to build this left product with a nested for loop, right, basically saying, okay, for this number, take a look at all the numbers at the left. For this number, take a look at all the numbers at the left. For this number, all numbers. For this number, all numbers. That's just Gauss's formula, right? So that's just still O of n squared, right? Yeah, so this is more so, I feel like a dynamic programming question where we're building the product array ground up, right? So I have this, right? The right product will be the same idea, right? Start with 1 on the right side and then start in reverse order this time. So left product at, so left p at I is essentially going to be equal to left p at I minus 1 times nums at I minus 1. Is that what it was? So if we're computing this one, right, again, it's just the number it was before times the number it was before as well. This one is just the number it was before times the number before. Yeah. Same thing for the right product, right? The right product would be, let's say, again, I had 1, 2, 4, 6. Starting from this side, right product will be 1. Starting from this side, the right product would be just 6, right? Because we're taking this number and multiplying it with this number, so 6. 2 is going to be 4 times 6, which is 24, and so on. yeah, so, and then we're going to build the right product. So right, right. This time we would be in reverse order, right? So it'd be I plus 1 this time, and then plus 1, right? And then build that output, right? This looks solid, right? Basically the idea here is that pre-compute the left products of each I. Pre-compute the right products of each I, and then output at I is just equal to the left product times right product. Yeah, so some things to know about this solution though is that the runtime is going to be O of, I guess, 3n, assuming that this is just another loop, right? But this is also just equal to O of n, asymptotically equivalent. And then space complexity here would be, so this is the tricky part. Space complexity would actually be O of 2n, which is, again, asymptotically equivalent to O of n, right? On LeetCode, it says this is a follow-up. We can do that follow-up later. Let's just try and implement this solution out first. Yeah, so let's start it. So we get the size, right? We're gonna have a vector and the product. I'm gonna actually just say n right here, right? And I guess we need another one going to be for the right product. Okay, so for size t, I is equal to 0, right? I is less than n plus I. I guess we want I to start at 1 instead, because the left product will always be, the first element in the left product array would always be root 1. So left product at 0 is going to be equal to 1, right? Let's check our constraints really quick though. Let's go back to LeetCode's constraints. Notice that length is always going to be 2, right? So it's either safe to either start our indexing at 1 or to start our indexing at n minus 2. So that should be fine to start at 1. Okay, so now we're going to say left product at I is going to be equal to left product at I minus 1 times nums at I minus 1, right? And to build the right product, it's essentially going to be very similar. Right product at n minus 1 this time, and then start at not n minus 1 but n minus 2, right? N minus 2 would put us at this index right here, which is where we want to start building it from. So change this to greater than or equal to 0, right? And then this is just minus minus. This is a plus. This is a plus. Right? And right. Okay. And then now our answer, or our output, I guess. So answer vector would be built like this, where again, size of n, right? And then for size ti is equal to 0, I is less than n, plus I. We would say ans at I is going to be equal to left product at I times right product at I. Then we return the answer, right? So hopefully that should be it, right? I'm gonna actually test this out before I submit it. Product accept self. Let's do vector and input 0, 1, which will be 1, 2, 4, 6. 1, 2, 4, 6. Output 0, 1. So this is expected output. Right, let me make my solution class, and then I guess let's just say vector and actual output, right, is going to be equal to solution dot product accept self input 0, 1, right? Ooh, maybe we can do some sort of insert here. Let me see, insert in C++. Assert b does not equal to 0, right? How can we do an assert in C++ with vectors? You get friends. Plus assert. Okay. What does asserts even take in? So it's a macro. Okay, let's learn about asserts really quick before I submit my solution. Reason I want to learn is just because I do want to start building out test cases for my chess engine, and I believe asserts are the way to build it. That's chat. So let me put this to the side. Can you explain what asserts are in C++? CPP reference is saying it's a macro. So that means a block of code replaces the assert call wherever it's used. Correct. But what does that block of code look like? And yes, it's a macro, not a function. Okay, conceptually, this assert x greater than 0. So reading this is just saying, make sure that x is greater than 0. If it's not, then just throw a bug, right? So this gets expanded out. Okay. So it takes in a Boolean, essentially, right? Because it's some sort of expression, and we're using it as a ternary. Okay. If it does not behave like a function, x++ won't run at all. Should rely on this. It's for debugging, not logic. Okay. Of course, yes. So certs for more so for debugging and test cases, not for logic. So the thing I was wondering though, so it looks like certs only take in Boolean expressions. Is that right here as well? I need to learn how to read this, because to me, I don't see where it says it's taking in, I guess, okay, it takes in a condition. Okay, so if we are expecting a condition, right, how can I assert a vector? How would you assert a vector in C++? Say you have an actual versus expected vector. So you have an actual versus expected vector. How would you compare that to using asserts? Oh, okay. I guess they have an operator equal overload function, and it just compares them one by one. Okay, so given that, then we have our actual output, right? Let's say, is it std assert? No. Is assert a part of standard library? Okay, so assert, right, the expression of the actual output is equal to input or output 0, 1, right? How do they write text? What do they write? So there are 5 lights. Here, I'm gonna go here, right? Test case 1. Left operand of comma has no effect. Oh, okay. There's no standardized interface to add additional message to assert errors. A portable way to include one is to use a comma operator provided it has not been overloaded. So this is valid. This is valid to add a message with the assert. Okay. So this is basically, it does nothing, right? Because it's trying to evaluate as expression, doesn't do it, right? So it evaluates test case 1, does nothing. So it's essentially treating this as some expression and it's evaluating it and does nothing. So it's saying that don't use this, right? Instead, just treat it as some conditional, right? Then we can say something like std error test case 1 fail. Oh, what? Combine message plus condition. Well, what's the point of having this there, though? How would you use asserts to write test cases in C++ with helpful messages? Oh, I guess we just get assertion failed. Okay, let me try this first. Yeah, so let me try this. CD product array, std. I forgot my flags. How does it go? Compile with C++ 20. Okay, so it's C++ 20. Wait. Okay. C++ 20 main.cpp dash raw dash. What are the other flags? Pedantic. I'm gonna compile with debug flags, right? Okay, really quick though. Assertion failed, actual zero expected. Oh, I see. Okay. Okay. Oh, I had it. Okay, I had it mixed up. So it's the flags first. Wall dash W pedantic dash W extra. Is that what it was? And dash G. Dash wall means display all warning, or despite the name, it does not mean all warnings. Okay, interesting. Enables unused variables, missing return statements, type mismatches. Okay, so nice. So we have basically warnings, but not all of them, but more specifically type mismatches, unused variables, and missing return statements. Basically what my linter catches. Extra is more strict warnings, such as unused parameters and so on. So these are just stuff that, okay, wait, the W pedantic means non-standard extensions, compiler specific behavior. Include all debug info. Okay. Warnings become errors. Okay, so I'm assuming this was what will allow me to not compile despite having warnings. Okay, so if I were to just say this first, right? C++ 20 and then main.cpp dash o main. Right, I had a warning there, but it's still compiled, right? I have main. I have an executable called main. I is greater than or equal to 0 is always true. What does that mean? So let's go here. I mean, aren't we decrementing it though? Assertion fail. Okay. So basically, this does not equal this, right? If I were to print it out though, actual output, cout, st cout, num, and then cout doesn't even get to run, right? Let's say I commented that insertion out. This size failed. And -2. Is it just throwing me an error? How can I read this? Let's go here. Oh, what? How does it constant expression operator reference size type long and assertion this size fail? Oh, okay, so this is my index, right? And it's this insertion failed, so it's accessing it over. Okay, so to recap, basically it has its own assertions, funny enough, saying that my index is supposed to be larger than or lesser than the size, but it's actually equal to or greater than the size. Which part of that is saying it here? Does it tell me which line though? Does it tell me which line it had? I don't feel like using GDB right now. So, where am I accessing it? Let's do this. Okay. So right product is of size n, and then we're saying n-1, right? So n-1 should have been valid. Size t n-2. So the problem is this right here. Okay, what's going on? So I is equal to n-2, while I is greater than or equal to 0, minus I. Right product at I is equal to right product I plus 1 times num at I plus 1. But I starts at n-2. Right, so if n was 4, right, then it will start at index 2, and then plus 1 will give it index 3, right? I, and then of n. Oh. stops early, right? Oh, wait, no. So it goes to 2, then 1, then 0, right? Okay. Oh my gosh, that's the problem with size T. Okay, so the issue that I was running into, right, is because of this size T. Size T is, what is it? It's a unsigned integer. No, wait, unsigned integer, meaning that it can only accept positive integers. And what I'm trying to do here is my logic relies on the index at some point to be, is that the case? Some point to be 0, right? Wait, no. Is the size T the issue? Because, okay, let's look at this output, right? I is of 2, then I is of 1, then I is of 0, right? How come it's going one more? Shouldn't I be... Oh, okay, it is the integer problem. Okay, so size T, what it is, right? It's an unsigned integer, right? Meaning it should only be positive. But the moment we decrement it, so let's say I is equal to 0 right now, right? If we do I minus, this won't be -1, right? This would actually be some garbage value because size T's don't have a negative side to it, right? So I needed to reach -1 so that this would actually throw a false, right? Not throw an error, but become false. So if I say this, right, will this work now? Hopefully. Okay, now I get no warnings, and now I get this. Okay, nice. Okay, so I'm actually getting the output, right? I'm getting 48, 24, 12, right? And this assert. Okay, let me see what this assert would return or give us. Right, assertion actual output is equal to output 0, 1 failed. That's because output 0, 1 should be 48. What is it? 48, 12, or 24, right? This is 12, and this one should be 8. Now again, let's compile, right? Dash wall for any extra warnings. Dash, what is it? Dash pedantic for more strict warnings and extra, right? For any extra errors. Let's say, okay, basic warnings, stricter warnings, standard compilants. Okay, so basic warnings, stricter warnings, and then basic compilants. And then the version we want to compile in, std is equal to C++20, right? And then main.cpp, main. Okay, nice. We don't get any assertions now. One thing I want to test out though is that if I were to go here and say error, right, this will compile, right, because I don't have any warnings. But what if I change back to this size T? This should give me an error, right? Okay, nice, because it's comparing that, it's making that warning into an error, so now it's not letting me compile at all. It's actually kind of nice. Alright, so change that back to int. I'm gonna grab this, go back to my problem and submit. See if good. Nice, submit. Okay, nice. But now let's try to do LeetCode's follow-up where it wants it to be in O of 1 extra space complexity. Okay, so how can we make this O of 1, right? So given 1, 2, 4, 6, for building our left product, right, maybe we can just build it in place, maybe. That's the only way I see this being extra space. So same logic, but building it in place of having these extra vectors, right? So let's actually expand this out to a bigger So we have 1, we have 2, we have 4, and we have 6. If we were to build this out, right, so we have to do 2 traversals to build it in place, one going forwards and one going backwards. If we were to build this out, right, we would start right here and be like, okay, well, the product is going to be the product of this times maybe a product that we keep track of, right, to say like curve product, right? So this will be 1, right? So this will be 1 times 1, this will be equal to 1, right? So the left hand side of the product is going to be equal to 1. Ooh, actually, okay. So we can't build it in place in respect to the input vector we're given, because I don't think that's possible, because were to traverse it this way, all these values will be lost, right? They would be updated with the left product given that index, right? What happens when we go this way, when we want to build the right side with the product? Now those values are lost and we can't access them anymore. So instead of building it in place given the input vector, I think we could build it in place giving our answer vector. And I do not believe that the answer vector counts as space, because that just sounds dumb. Like, why would the answer they're expecting us to be added into the space complexity? I think what they're trying to get at is that they don't want to see the additional creation of these 2 vectors, the left product and the right product. So say we had our answer vector right here, right? If we had our answer vector right here, we would just build the left product normally as we did before, right? So this would start off at 1, right? This would be this times the one before that, which is 1, right? This would be 2 times 1, so 2. This would be 4 times 2, so 8, right? And instead of creating the right-hand product array, we would just use the same array, right? So starting from here, right? Let's say our current product now is equal to 1. We would just do 8 times the current product times 6, which would be 48, right? So this would turn into 48. Now if we were to go to here, what would this be? This would be, and then we would update the current product, right? This would be updated to be 1 times 8, so this is now 8. Or is that right? No, the current product will be updated to be 6, right? So 6. Yeah, so now this would be 2 times 4 times 6, which is, no, that would be 48. Am I on the right track here? Okay, let's rewind, right? So this is our left product essentially, right, being stored in our answer vector. If we want to build a right product, what would that look like? So if we were to build that right product, it will look something like this, right? Going back to our initial approach, right? This will start off at 1, and then the formula is just to do I plus 1 times I plus 1 here, right? So this will be 6 times 1, right? And then this would be 6, right? And then so on. This part right here would be 24, right? Because it's just the one before times the one before, right? So if we wanted to combine this and build it into place, we would keep track of what I plus 1 would be given I, right? So in this case, we could just say I plus 1 would be 1, right? And so the right-hand product, right? The right-hand product would just be 1 times whatever it is here, right? Which would be nothing. Since this is nothing, it would just be 1, right? So right-hand product is 1. And then we would just multiply this right-hand product to this current value that we're currently looking at. So this will stay 8 actually. And then if we were to go here, right, we would update the product to be the index that it was before, right? So this would now be 6. And then right product would be oh no, this will, when we keep it there, right product would be 6 in this case because it's what it was before, right? Okay, I think think I'm tripping myself out. Let's restart this tracing over, right? So again, we built the left product in place in regards to our answer vector, right? Now, how can we get the right products, right? Well, if we were to start at this index, right, we know that we actually don't have to start at this index, right? We could start at this index because this answer is correct, right? The answer at the end is just the left product of the rest of the array. So we don't have to start at this index. We could start at this one if we wanted to. Okay. How can we do this? So if we wanted to build the right product of this at this point, right, is just simply 6, right? But we want to combine this with the left product answer, so now this should turn into 12, right? In order for us to compute the right product, wouldn't that just be, okay, so let's say it's 6, right? Let's move on, right? The next right hand product will be 24, right? So this would be 6 times 24, right? And the next one will be 6 times 4 times 2, which would be 48. Okay, so here's what I'm thinking. Here is what I'm thinking. So again, answer vector, right? We start here, right? Let's say product starts off as the last element in this nums array, which would be nums at n-1, right? So product starts off as nums n-1, right? We can just say that this part that we're looking at would be our I. We can just say now that ans at I is going to be equal to what it is, right? So I guess times equals, right? Because this is still technically our left product array. So we're taking the left product and multiplying it with what the right product would be, which would be product, right? And then for each iteration, we're going to update the product to be the current num that we're also looking at that this I is also pointing at. So nums at I. And that way we're building the right product, but we're storing it as a variable instead of storing it as a separate array. Okay. Yeah, sounds good. So let's do it. So let me comment this out though. Build the left product, the right product, combine the two products. Const size tn size. Okay. Alright, so what we want is to build it in place, right? First, let's just have our answer vector, right? And this answer vector at first is initially going to act as our left product, right? So build the left product within the answer array. Right, so we're going to go here. I'm just going to take this and put that there, put that there, and put that there. Okay, nice, right? So we have successfully built the left-hand side of the product. Now we want the right product in place of the answer array, right? So we can just say something like this. So we're going to keep track of the product like we said, right? The product will actually be equal to nums at I-1. Not I-1, but n-1, right? Int I is equal to 0, or I guess int I is equal to n minus 2 like we had before, right? And is greater than or equal to 0, minus I. Okay, and here what we want to do now is just say that the answer at I is going to be equal to the product, right? Because this is basically the right hand side product. And then now we're gonna update the right hand side product, right, to be nums at I as well, right? Does that make sense? So if we start here, right, the product is essentially, the right hand side product will be 6, right? Now what we want to do is update the product to be 24, so the next time we go here, that's basically 24 is the right hand product of this, and then we just multiply it together. So okay, this makes sense. Return answer. Hopefully I don't get an error. Alright, G++, again, just writing it out for practice. Extra pedantic error. Compile it with std C++20 and then main.cpp. Okay, assertion failed. Or wait, no. Wait, what? This thing again. I'm getting the same thing. I swear. I thought I didn't get any errors though. Before it threw me in a warning. What could the warning be? Nice. Okay. I believe we are getting the right output. Okay. Let's go here. Let's do this, right? Hopefully. Accepted and submitted in both areas. Accepted here. Accepted here. Nice. Alright. What is the solution? Did I have the right one? Looping the input array twice. That kind of sounds like what I was doing, right? Let me just see the code. Oh, nice. Okay. Yeah. Alright, so I think that pretty much sums up this one. Product array. Actually, wait. I probably should be doing that to restore staged arrays hashing body SL get status. Let's go to my get ignore in this. Did I do that right? To ignore executable files. Okay. Well, you can have that, but notice files like a.out, program.out. Keep tracking. Did seem to do it. Okay. Alright. Update that. Let me make sure. Alright. Okay. What's next? What's next? Longest consecutive sequence. Okay. A consecutive sequence is a sequence of elements in which element is exactly one greater than the previous element. Okay, so a continuous sequence, right? And we want to find the greatest continuous sequence. In this case, it would be 4 because 2, 3, 4, 5. Alright, doing it over in time. Alright, so the naive solution that I was already thinking of is just to sort it and then to loop through it once and then count it. But that will be n log n because of the sort. So, longest consecutive. Oh god. Okay. Longest consecutive sequence. And here I'm going to say name.cpp nodes.me. Consecutive sequence, and then just return, like just having it fun for now. Oh, before we start though, I forgot to check if this is good. Alright, try to check if this is good. C++ 20 semantics. Product of array except self. Is this good? C++ 20 semantics and practices. If not, what can I do to make it better? missing edge case. Okay, well, in the constraints it said nums would always be a size of 2 or greater. Signed versus unsigned mismatch, he wrote. Clean plus safe reverse loop. Oh, interesting. Okay, I guess that's how you can write it with a size T. But to me, that seems kind of hard to read. And if I'm coding for, let's say I'm sharing a code base or I'm coding in front of an interview, I feel like that this would just make it harder to read. More readable. Option B, more readable in my opinion. Okay. We just start with 1 to begin with. Okay. So, really, this is all I got from it. This could be written as the way he suggested, but it just looks unreadable. 1, right? Remove the need for this. Remove the need for this if I had 1 to remove. Okay. It's fine, I guess I'll just add it. Raise hash of the product, main.cpp. Clean up. What was I on? I was on, not that one, we finished that one. Longest consecutive sequence. Alright, this is the notes NP. Alright, sorry. Alright, I'm ready. Alright, so again, we want the longest consecutive sequence, right? So notes, brute force right off the bat is just to sort, but this will be n log n, but you want it to be O of n, right? So what's another solution? Say we had this, so 2, 20, 4, 5, 10. Right, what was it again? 2, 20, 4, 10. 2, 20, 4, 10. Ooh, 4, 10. 3, 4, 5. 3, 4, 5. Alright. So we want to find the longest sequence, right? And I guess the issue with this is that, okay, brute force would be, okay, look at here. For this one, scan the entire array to see if anything smaller than this exists, right? Because if anything smaller than this exists, that means that we technically can't start counting our interval here, right? Because if we started counting our interval here, right, and went like this, oh, this is the next highest number, increment that longest streak. The issue is that what if this number wasn't the start of the interval? What if, for instance, that there was a 1 hidden all the way at the end, right? Then we would essentially be like, okay, start here, find the next number, which is this one, increment that, which is the next number from 3 is 4, the next number from 4 is 5, is that. So we're going to say the longest sequence is going to be 4, but in reality, the longest sequence was 1, but because of our algorithm, we didn't account that in the case that this isn't the start of the sequence. So there are a couple ways that I think that we can solve this. First, loop through all of this, honestly, and then store it in maybe some sort of set, right? I'm saying set instead of a map because I don't really need the key value pair. I just need a singular key, which is the element. So this is going to hold our integers, right? And it's going to store this as a set, right? Now we can loop through this and be like, hey, check the number we're at. So number we're at minus it by 1, right? And if this exists in our set, then we know that this isn't the start of our interval. So keep going on until we find one where I minus 1 doesn't exist, right? In our case, 20. So 19 doesn't exist in our set, so this is the start of an interval. Granted, it's not the longest interval, but it's start of a some interval within this array, right? So from that, now all we have to do is just iterate our set and continue counting upwards, right, until it doesn't exist. So now we're going to be like, okay, does 20 plus 1 exist? Nope, it doesn't. Okay, longest streak was 1, right? And we're going to continue on that way. Same thing with 4, right? Check for, hey, does 3 exist? Okay, 3 does exist. But check again, does 2 exist? 2 does exist. Check again, does 1 exist? 1 does exist. Does 0 exist? No. So this is the start of our interval, and then we're going to start counting up, right? So I think that's the idea. So solution is create, okay, I guess I'll pseudocode this part out as well. Create a set of the numbers in our vector. It's also fine if it's a set because this doesn't really matter. Duplicates shouldn't affect our solution in any meaningful way. So create a set of the numbers in our vector, then iterate through our set. And honestly, maybe if we use a ordered set C++, takes login time. Oh. Is login, but for an unordered set. Is O1. Okay, so I was also thinking maybe instead of just using some random set like an unordered set, we could just have a normal std set, which is basically an ordered set which will automatically sort this in place. That would be helpful, but it's saying that the dot find operation is going to be login, and that's kind of bad in our case, right? Because worst case scenario, we're iterating through it O of n times, and for each element we're going to be doing a dot find, so that's n log n, versus a constant time will just give us O of n. So create a set of the numbers in our vector, then for each number in vector we're going to say start number, right, is equal to -1, and it's one of our edge cases. So numbers I could also be a negative. I think it's fine to set it as like -1, or maybe just like and something like that, right? So if set contains, right, number -1, right, then start number is equal to number -1. And I guess this would actually be not min, but number, right? This would be start number, contain start number -1. And then we could just say start number. My phone is going off. Alright, so we have this, right, minus start number, and then once we found the start number, then find the longest interval, right? So then we could say, well, set dot contains start number +1, count ++, and then start number ++ as well. So that's my idea behind it. Alright. So let's do this. Alright, so first what we want to do is create our unordered set, right? Create our unordered set of integers, right? Call it s, and then for each number in nums, just copy it over to our unordered set. S.insert, right, num. So create our unordered set of numbers. Alright, now what we want to do is find the longest interval, right? So we would say answer is equal to 0, right? And then, or maybe start it at 1, right? Because regardless, if the numbers vector always has an element, then at minimum, actually no, nums.length could be 0, right? So that's one of the edge cases. Let's go to here. Oops, sorry. Alright, so go to here, right, and just be like, if nums.size, or if n is equal to 0, then just return 0, right? Else, we're saying that numbers does have some sort of number in it, so the longest interval is always going to be at least 1. Then for each number in nums, right, actually go like this. Alright, for each number in nums, we want to find the start number, so set it equal to nums, and then we're going to see if the number minus 1 of the start number exists. That means that we're not at the start of the interval, right? So if s.find start number minus 1 does not equal to s.n, right? So this is saying well, what we're saying here is find the start number, right? So if it does not equal to n, that means it does, our set does contain start number minus 1. So we're going to say minus start number, right? I think that's fine, right? And then we're going to say count the interval, count the sequence, or so. So s dot find start number plus 1. So if it does contain plus 1, right, we're going to increment our answer, and then we're also going to increment start number. So start number. Alright. And then return ants. That should pretty much be it for this one. Hopefully I got this one right. Okay, got this one wrong. So my output was 16. The expected was 4. Let's go here. Right. How did I get 16? There isn't even 16 elements in this. So, okay, let's think about it, right? So for each num, right, we're saying find the start number, given number, right? And then start number plus 1 is not equal to s.n, and minus increment ants, and then increment start number. I mean, this makes sense to me. Alright, I have class in 20 minutes. Let's see if I can finish this. And start number is equal to num, while s.find start number minus 1 does not equal to s.n, subtract the start number, right? So then we keep doing this until it's not in the set, right? So now we have start number, right? And then we want to go up again and find the longest sequence. So plus plus start number plus plus ants. My question is, how is ants reaching 16? That doesn't make sense. Okay, I'm stupid. Alright, I just wasn't resetting it. Let's see if I can just grab this, paste that there, and then do a little bit of that. That should be it, hopefully. No? Into max is equal to min, right? Then at the end, max is equal to SC, max between max and ants, right? Actually, I'm gonna say this is ants. I'm gonna rename this to ants. Rename this to count. I'm just doing it here, it's faster. So solution or so ants is equal to 1, or in right? This is gonna be our count, and then count, and then our answer is going to be the maximum between our current answer or the count that we just found with the sequence, right? And then return ants. Let's do that. Grab that here, paste it to here, and yeah. All right, let's see. All right, nice. Nice. Okay. Let's see if it passes LeetCode's one. What was it called? Longest consecutive sequence. LeetCode. Oh, it's like I did do this one before. Oh, interesting. So I didn't have to keep going backwards to find. That's an interesting approach. So my approach, right? So it's like past me did it better, but essentially what I was saying is, okay, if I'm on here, right, I want to see if 3 exists, right? Because 4 is potentially not the start of the interval. If 3 exists, now I want to see if 2 exists. If 2 exists, now I want to see if 1 exists. If 0 exists, then it doesn't, right? Which it doesn't in this case, so this is the start of the interval, right? And I'll continue counting. But past me was saying that that was unnecessary and that I could just continue iterating through this all and find, because we can visualize this vector as multiple intervals. They're just split up, right? So no matter what, as long as we traverse through this, we're gonna hit the start of the interval at every single interval no matter what. So there's no point in having to backtrack and finding the start of the interval for each number. We just have to see if the number nums minus 1 exists in the hash map. If it doesn't, then we can continue counting upwards, right? So I think that's what is making mine slow. We could just simply say this, right? If s dot find num minus 1 is not equal to s dot n, or is equal to s dot n, so it, oh wait, does not equal s dot n, that means continue, right? Find the start interval. Continue if not start of the interval, right? Now if we don't hit this, that means num is the start of an interval, so then we're going to continue counting, right? So then we can just say num here and num here, right? And hopefully that should be the same thing. Just kind of nice, honestly. So no ants. Alright. And does. Nice. So that ran me from 4 to 2, I think. I'm not gonna resubmit LeetCode because I already have here. But yeah, alright. So that should pretty much wrap it up. The next video would be system design. So I'll step away from LeetCode for a little bit. Gad. Completed longest consecutive sequence. Wait, before I do that, I'm getting some sort of error. Is it bad if I use an I'm getting use of declared identifier for this line? C limits. Okay, so I need C limits. Okay. Alright, so that should wrap it up.